Hey guys, it's Vince. Today in this video, I'm on the workbench with a client system, and I want to discuss this particular system because I do get a lot of questions regarding a build of this caliber as far as the feature set it has. Now, this particular system is going to Shan over at WERKZ Holsters.
Personally, on LinkedIn, who Shan Hemphill is, once again based in Princeton, Idaho. We'll come over here and we'll look at his experience. He's the owner, once again, of WERKZ Holsters. I'm going to cover that website in a moment. I want to just give you this individual's background. Ops manager at Micron Technology. He was there February 2014 to September 2020. Intel Corporation prior to that, 13 years firmware engineering manager, program manager, IT director, eRepublic, systems engineer, Intel Corporation, system consultant, Optimal System Integrators, and again has his Juris Doctorate degree from Lewis and Clark Law School. So again, very, very highly educated individual, well-rounded. I'm very proud to be associated with him, as well as Boeing, as well as Applied Materials. But what I wanted to show you as well is his amazing quality to his products. I get asked all the time, what separates companies in terms of, how do I sell things online? How do I become successful? Automating is great. How do I become successful? I know a lot of guys that can buy robots and produce amazing quality products, and then other clients, they'll buy the same robot, whether it's a 6040 or, whatever robot they're purchasing. And in this video, he's highlighting his 6040s. So when I hear guys saying, what can I do to make money? I hope you guys take this video testimonial and run with it. I hope it inspires many of you, because when I seen this, and I've talked about it on my channel numerous times, and you get to see this before your eyes, this shows you what's possible, okay? Again, Shan's company is really selling lots of different holsters for small arms, and I highly recommend, if you guys are into firearms, check them out. They're all over Amazon. The quality is amazing. Again, he's just an amazing guy with an amazing company. Check them out. And again, I am very, very lucky and privileged to work with such a highly reputable company and a great guy. Check out his testimonial. And to all my subscribers, if you require any kind of consultation, support, if you are designing a system, once again, just contact me. You can message me, again, in the beginning of the video with all my contact information directly, storm2313@gmail.com. You can also message me through my eBay store, eDealers Direct. I'll do my best to get back with you. Thank you, and check out the testimonial.
Now, how often is it that you can find somebody on eBay that's going to provide you with a professional level product time and time again over the years? We've found that with Vince and his Gecko CNC controllers. Now, a number of years ago, we were looking for a way to drive commodity-based 6040 CNC machines a little bit harder, a little bit faster, and give us a better, more reliable result. Now, after a bunch of searching on eBay, we found somebody called Corvette Guy. His name's Vince, and he provides us with the best Gecko-based controllers for our CNC equipment to help us trim out and build our holsters in a reliable fashion. So those of us using CNC equipment know how important it is to have a reliable controller. Whether you're converting a Bridgeport or whether you're doing like we are and running a commodity 6040 machine, you need to have reliable stepper motors. You need to have a reliable controller. Vince is able to provide that for us. For us specifically, our problem was that we could not drive our controllers fast enough to get the feeds and speeds we needed for the quality level we needed, and also to get the job done in a reasonable time. We needed something faster, and we went ahead and we got that from Vince. His controller with the cables and the stepper motors allowed us to change over our 6040 machines and get those running at the speeds and feeds that we need. Not only does Vince have the kits that allow you to get up and going if you don't really know what you need, but he also has the expertise to help custom design something for you. For instance, he's gone ahead and helped us attach our VFDs to the Gecko controller and then run that from Linux CNC so that we can get spindle speed control. Now, our operation has almost a dozen of Vince's controllers in process, in work every single day. Not a single one of them has failed on us. We set them up, we get them configured, and we let them go. They are a reliable solution. The quality from Vince is top-notch. His expertise is great. I think he may be able to help you get the controller solution you need.
Once again, WERKZ has numerous versions of my controllers. He's actually purchased, Shan, 2 of these. This is the second one. Usually every year he updates and buys another system. Naturally, that means he's growing, which is fantastic. And what I wanted to cover here is what this controller is. You can see we have a DB9 here, and we have right here the breakout correlation to the DB9. Now, all of my systems, you know, or should know if you've reviewed any of my videos, come with wiring diagrams. This system actually supports dual relays to control forward and backwards motion of the spindle through the software, as well as spindle control using a DB9 cable. And then when we come over here, he's got all of his programming settings along with the wiring diagram that's done internally for this connector. Okay, so as we rotate the system, you guys can see exactly what we have here. You can see we have cycle forward direction, and then how this relay is wired. And then, of course, over here, we also have the cycle backward direction. And then we have the DB9 connector right here. And we have the ferrites installed on our signal cables coming from the G540 from outputs 5 and 6. And everything else here is very, very simple. I also put a redundant wiring diagram of the DB9 over here, which once again is so that if they ever had to work on their system, they would have this diagram present with the system open, and that's exactly what we want. Okay? Once again, dual relays are toolless mounted. Nothing new here if you're familiar with my channel. But overall, a very advanced system because of the capabilities that it possesses. Now, Shan over at WERKZ, they require that forward and backward direction when they're manufacturing their holsters. And again, this allows for that all within the software so that you can once again utilize a lot less manpower in terms of having to manually go over and change the direction of the spindle. The thing I want to point out, of course, naturally, if you were to purchase a system like this, and this is the question I get asked, do I have to use the second relay just for cycling a different direction of the spindle? No, you don't. You could use this relay for numerous different things. I've had clients use a secondary relay for everything from turning on LED lights, different laser type features, different switch type features, you name it. I mean, it's pretty much arbitrary to what application you decide to integrate using that secondary relay. But this is what makes the G540 very interesting and most appealing, is that it's an integrated drive. So that means we just have the drive right here. We have the power supply right here, powering the drive, and all the 4 drivers inside the G540. And then these relays are rated to 48 volts. What does that mean? That means simply that this power supply supplies the power to the relays as well, which means a lot less wiring and a lot less components because we're not adding another power supply to just support the voltages of the relay. So that's all done. Cooling fan is also 48 volts, so it runs off that power supply, and everything is nice and neat. Now, I want to cover something else in extreme detail because I'm still getting lots of questions on the SMCU. Okay, I've got the SMCU here, and it's mounted in its back plate for its enclosure. And the reason I have the SMCU here, of course, is because I'm getting a lot of questions in it being a direct comparison to the G540. Now, most of you already realize the SMCU will support motors up to 9 amps in size, which is absolutely massive. That's a NEMA 42, so it will easily handle large-scale mills like a Bridgeport. The G540, on the other hand, maximum amp output is 3.5 amps. So again, for smaller base systems, for Shan, this is optimal. He doesn't need any more than this. So it really doesn't make sense to have him step up to this system. Another case in point is the reason I wouldn't have him go to this system, even though this is the latest version of the most advanced 4-axis drive that's integrated on the market, is because he already has these systems in-house. Now, what does that mean? That means that I'm being honest with him to let him know that staying with this system allows him to use the other system that he has as parts, or this system as parts, should he require any type of components, because they're interchangeable. Now think about what I just said. There's a difference between being honest and just saying, hey, you know what, this is the latest thing that came out, you need to buy this. He doesn't need any more than this. So why in the hell would I recommend it? This is plenty for his applications, as for many of you it will be. But what I wanted to do is give you a visual example of just how advanced the SMCU is in compared to a G540. Now we see the two relays here that are mounted. We see the cooling fan mounted. We see the power supply mounted. That's it for this system, aside from the DB9 and of course the IEC power input port, the auxiliary port, and the fuse. That's it. The only difference with this drive in terms of what you're seeing here is the fact that these relays and all this wiring, it's already built into the motherboard. So you wouldn't have to wire all these in. The only thing you would be mounting inside the SMCU's enclosure is the cooling fan and the power supply, and of course the ports, because that's required just to supply everything power. Other than that, you are done. Now, when I say power supply, let me be concise. The SMCU, I'll show you here, has a built-in logic step-down power supply. It's 15 watts, it's made by Meanwell, you can see it right here. That will supply power to your auxiliary inputs, and basically that handles all of that. However, when you install your UC400, a more advanced control, like I said, an ESS or a UC400, you are going to have to step that up as far as putting in a step-down power supply to supply power for that separate controller. That is the only additional item other than this power supply, which once again, they're backwards compatible. The G540's 48 volt power supply is backwards compatible with the SMCU. Now, as I stated, these two relays, they're already built into this board. So essentially what you have here is all this additional wiring is already done. Think about what I just said. You have the same inputs. You have the same spindle control options, except you don't have to wire in these additional relays. Now, as I stated, the reason I would never recommend this to someone who already has these systems, meaning Shan, like I just said, already has one. If he already has one, you have parts. It's readily available. So if he stepped up to this, then he'd have to buy parts for this particular system if he decided that he wanted to keep extra parts on hand. It doesn't make sense. So you can see now visually just how advanced this is, and that's just tip of the iceberg, okay? The other features are, this has micro stepping at 1/10. This goes up to 1/256. What does that mean? This has 2,000 steps per revolution micro stepping. This has 51,200 steps per revolution micro stepping. So you don't have to use that resolution. Of course, you can adjust it with the dip switches, but thinking in comparison, that's massive, guys. Absolutely massive. The major difference that I think everyone needs to focus on, because a lot of guys are not aware of this, the G540's maximum step frequency is 100 kilohertz, as most integrated drives are. This drive can do 200 step frequency. What does that mean? The step frequency is what controls the pulses going to your motors. The faster that frequency is, the faster the motors go. That's why if you watch the video, the performance of what this drive puts out at 200 kilohertz in config, motor tuning. Let's go 5,000 RPM. And you know and I know the odds of you being able to use, once again, I'm stating this so there is no confusion. I'm not using smoke and mirror games. The usable RPM will be usually much lower than 5,000 RPM. That being said, how much lower we don't know because it's not connected to your specific transmission. But either way, you have a huge gamut of what's totally available or what's considered available on a stepper motor, if this is even possible. Steps per left again at 10 times micro stepping or 2,000 steps. Acceleration still left at 35.25. We're going to save the axis settings now. We'll watch the bar graph. Look at that bar graph. Interesting. Let's click on OK. Let's see if this will hold it. Definitely a difference in tone. Let's see if we hit it. And that's 4,999. Let's see if it'll go back. There it is. 4,999. Checking the inch per minute on the screen for Mach 3. Registers the same. That's 5,000 inches a minute, guys. Or technically 4,999. So let's do this. Let's see where the envelope is. I'm going to hit motor tuning again. Now, we're going to come over here. Go 5,500. Once again, steps per 2,000. Once again, 10 times micro stepping. Acceleration, once again, still set at 35.25. Going to 5,500, save axis. And you guys will notice I just saved the axis at 5,500 and it went down to 5,100. So, believe it or not, this is Mach 3's envelope. The software will not allow us to go any higher than 5,100 inches a minute. This is interesting. This will definitely be a record. I don't know of what world record because technically I've never seen a stepper myself personally go this fast. Regardless of it being loaded or not, this is really impressive. I hope you guys appreciate what you're seeing because if you go and do a search, even through Google, through most of the online research, steppers top out, we know at about 3,000 RPM. Once again, whether this RPM is totally usable, that's negatable, but looking at this is amazing because this motor in theory should be stalling well under this. Let's see what happens. Starting to jog, let's see if she holds it. I'll go to 0 this time because we're far away. Definitely hear a tone difference. 5,099. Let's see, it just loaded. There it goes. 5,099 RPM. 5,100, 5,099 through Mach 3. Look at how fast it's covering that distance, guys. In terms of RPM, that is why you're able to achieve literally twice the speed because those steppers are once again going to get their step pulses much faster with this option of this drive. So when we hear that argument, and we've heard it a lot, these guys that say, oh, well, servos are so much faster than steppers. Once again, there's many variables here. Most of the guys that honestly argue that point, my argument right back to them, and always the first argument that matters, is what's your ROI from your speed increase? Is there any? Because if you can't quantitatively show me an ROI on that, you're pissing money away. Fact. The rest of it's just bragging rights. That's up to you, the end user, if you're cool with that. What I'm stating here is that in direct comparison of two drives with the same capability, because again, this drive does go higher in amps. Other than that, they have virtually the same capability. If you were to run motors back to back and one's running at 100 kilohertz and one is running at 200 kilohertz step frequency, the RPM on the two motors are going to be vastly different. Vastly different. So much so, in one of my videos, one of my motors hit 5,000 RPM, I believe. So I can tell you right now, thinking about that, and of course that RPM is not totally usable, but I'm stating a point here that you need to be aware of. There is a vast disparity between these two drives when it comes to performance on certain systems. It's not going to be beneficial to all. And that's why I still recommend get a consultation with me if you have questions, because why buy more than you need? Shan trusts me. He says, Vin, go with what you think. And that's exactly what I did, because there's no point in him spending more to get essentially the same operation. And that's the thing you're looking at. So looking at these, giving you guys a direct comparison, I think it really now gives you visually more or less what you're dealing with and how vastly different they are in terms of workload. Like I said, you're looking at 8 additional leads right here on top of all the mounting for the relays and then on top of the port right there. Now, of course, the port, whether it's on a G540 or the port on the SMCU, it's still going to have to be done. But when you're talking about wiring and relays, look at all this additional work in wiring. You still would have to do all that, where on the SMCU, it's already done. So that's just the workload capacity as far as doing the actual manual labor and the extra components. We're not talking about the other features. So think about what I'm saying. But now, as I stated, you have 2 options. The G540, if you're working with a smaller system like Shan usually stays with a 6040 chassis. And just so everyone is aware, and I can't emphasize this enough because this is a very, very good point. A lot of guys that think these smaller chassis are what they call hobby. The term hobby in this industry really has no place, because Shan has been making a full-time business with that chassis, and it's virtually the same size as my desk right here. So I'm telling you right now, the size of the chassis means nothing. It's the mind behind the chassis that dictates what they're going to make. ROI is everything. The rest of it is bullshit, and that's the fact. And if you don't believe me on that, I'm telling you right now, you look at the world's best jewelers, they're not buying all these 8x10 tables. They're buying tiny machines that do exactly what they need. Fact. So think about what I'm telling you. You don't spend more than you have to get the job done, unless, and I get clients too that'll say, Vin, which one will let me upgrade later on? Well, what table are you using? What variables are we working with? Because I'm not going to make a recommendation blindly. If you tell me, hey, I'm starting with a small chassis, a 2x4 chassis, and then I'm going to go up to, an 8x10. Well, again, if we go that large, the SMCU is going to be your best bet. If we're staying with a smaller chassis, then the G540 is your best bet, unless you say, I'm starting smaller, like we just said in that analogy, you'd want to go with the SMCU because it would work with both. So that's the beauty of now having 2 choices for integrated drive, not just for you, but for me, because I give you guys the choices. I just present you the options and you decide, where do you want to go? And do you really need it? Because let me tell you what, regardless of all the extra additional features here, the G540 is still super powerful when configured correctly, calibrated correctly, and put into applications that it's designed for. You're going to make money if that's what your intention is. So think about that. Shan knows it, and that's why this system is plenty. This system, once again, if I have clients doing 8x10 plasma tables, this would be your gold mine. Because I've had a lot of clients ask me, will that work with a plasma? Yes, it will work with a plasma system. So again, you've got the direct comparison, and I hope I've made it perfectly clear on what you're working with and additional work that's required. Because let me tell you what, Shan is also getting a configured VFD. I'm going to show you, I'll cut in because I did another video a while back on the first one of these that I produced for him, and I showed how I integrated the VFD. Okay guys, you can see here, we've got the VFD set up, got the spindle set up, and this is just a test configuration. I'm not using anything out of the ordinary. I'm just testing everything. I got my silicone mat here for the spindle. VFD is set up. This VFD has a full wiring diagram for the DB9 connector with mounting bracket that I've integrated. Now I'm going to show you how clean this can be done. Okay? This allows the client to wire this in seconds. Watch this. Look closely. Pop this. That's the way this should be done. We have thumb screws, or excuse me, thumb nuts right here for quick mounting, metal bracket, DB9 connector. Here's your jumpers, and everything is connected. White lead DCM. We've got a reverse lead for blue. Forward is black lead. ACM is orange lead. 10 volts is purple lead, and VI is brown lead. Now, if the client has any questions as to what is what, everything is allocated here in color configuration. So it's very simple to hook up and very simple to work with. Now, you can also see I've got the jumper set to the left side, which allows us to manipulate the actual spindle speed through Mach 3. This is a must. If you're working with this unit, the stock setting of this jumper will be on the right side. You want to be on VI. See if I can just pan it up. And you can see VI right there. So that's a must. Okay? Now, as far as the breakdown of what these control, we can cover that, and I'll put that in the video as well. I will do that after. I'll put it on the screen so you guys can see it. I'll edit it in. But right now, excuse me, you can see we're at forward. I will be able from the software to switch to reverse, and I will be able to control spindle speed. Now I've got Mach 3 right here. I've already set my spindle speed at 1500. Now why did I do that? Because that's the minimum speed, once again, that I want to idle at. I highly recommend you do that first. Do not leave it at 0. If you leave it at 0, you will get an error message. And do you know what that error message is? For those guys out there that have already done this, PWM bump to minimum setting. Okay? And what that means is, because I get questions on this too, is that your PWM signal that we've set at 5% for this particular unit is going to be set at that minimum level because you cannot go to 0 RPM, in which case it's beneath the actual percentage we put. So if I put 0%, for instance, on the PWM signal, this would go away. As soon as I exceed or go with the PWM signal, you'll see this go away. Watch. I'm going to clear this error, and we're going to come over here one more time. We'll enter it in one more time. As soon as I enter that, you don't see that anymore, and I'm going to hit spindle start. Very simple. I'm just going to press the button. Got the tape on, and you can see she's spinning. Okay? And again, she's at 1500 RPM. Now, if you look at the VFD, you can see we're very, very close. Now, of course, Mach 3 is not going to read the RPM exact. Why? There is no way for Mach 3 to read RPM. There's no tachometer. So I get questions on that a lot. You're going to have RPM fluctuate, and you can see it's very, very close. We're within 100 or just under 100 RPM. This is idle speed. Once again, he's not going to be doing cutting at this speed. You can see a rotation. This means that we're displaying RPM. When you're selected under rotation, I get asked, how do I actually move the LEDs to give me different readings? Just hit shift. And you can see now we've got hertz, we have amps, hit it again. Now you have amps, you have rotation, and you can keep doing this until you cycle to what you want to read. Amps is very good to see, especially if you're using a new end mill. I've said this in previous videos, to see what kind of load you're putting on your spindle. The higher the load, usually the duller the end mill. It's a good way to determine if you need to replace it. Anyways, we are moving in forward direction. Power is on, of course, and our rotational RPM is set at 1500. Now, if I decide I want to program in any speed, let's say 5000. Now she's accelerating. You can check the tape out. Okay, once again, we're still moving in forward direction, right? So I'm going to go back down to 1500. Hit enter. She's back down, and now I'm going to go over to my MIDI, and I'm going to select the opposite direction. Once again, we are moving forward. I'm going to type in M4, and you will see her stop and then switch over to reverse. There you go, same speed. And you heard probably the relay click. So again, you can see exactly how this works. If I want to toggle a different speed, I just come up here to MIDI, go to 5000. I'm just arbitrarily setting this. I can go up to 24, but that tape will get loose like that. So, we'll slow it down. There we go. Okay. But it's that simple, guys. I'm going to turn off the spindle now. I'll pull off the tape, and I'll show you going to full speed, because I know I'm going to have questions on that. Will it go full speed? Of course, it'll go full speed. Turn it back on. You can see the spindle actually, as soon as torque is increased in the motor, you'll see it actually move. We'll go to 24,000. You'll see it go right up. And you see just how smooth this is and how quiet it is compared to when you're dealing with a regular wood router. Once again, very, very, very close. Very, very close. Couple hundred RPM off, and we're right on. Turn it back down. Come back down to 1500. We'll switch direction. We're in forward rotation right now. Switch direction once more. You notice I'm only doing it at low RPM when I switch direction. Now we're going the opposite direction, and you can see that right here. Reverse. I'll switch it again to M3. You'll see it switch over. Forward. One more time. And now it'll switch over. So again, guys, you can see once again how small my leads are. Do you see the length we have here? And if you look, we have a nice, beautifully machined edge that when we set the cover on, we're clean. There you go. This supports the mounting bracket, supports the cable. This is one of my G540 motor cables because it's double shielded. And being our leads are so short right here, we don't have to worry about noise because we're literally running about maybe 3-inch leads. Every ferrule is soldered on as well as crimped. It doesn't get any easier than this. And again, the thumb nuts allow for easy servicing. He can remove this at any time and he's set to go. So, very, very simple setup. Not a cheap setup because there's a lot of work here. I'm not going to lie. Between the system, this, and the way we have it all configured, it's set so that minus an ATC spindle, this is as close to autonomous as you're going to get in the terms of end user support. Because at any point in time, he's controlling this. Once again, we switch direction. Boom. And that's exactly what he's purchased again, is another VFD that I'm configuring to support this system. So all he does, he'll get that unit in-house, he'll program it then to support whatever spindle he's working with, and he's ready to hit the ground running. And that's exactly what he paid for. No questions, Vin, just do that. I get a lot of my clients like that. Once they get one system and everything is smooth, they're like, let's move forward with another, and they'll progressively do it every year. Shan is a business owner. What does that mean? That means that he's writing this off. This goes on his taxes, and he writes this off. How do I know? I have an accountant behind the camera right now who is a corporate accountant for McDonald's. That's how I know. So if you want smart business decisions, the first thing you look at is what you can write off. He knows that. He upgrades every year. Super smart thing to do. So again, guys, I hope that this video has been helpful. If you do have questions, and the biggest question I get, and I'll hopefully answer it real quick, is that can you retrofit such and such machine? All I need to know to retrofit whatever you're building is what size the machine is. If you have a custom artisan robot that you're working with that you want to design, don't ask me generic questions and expect that I can go into full detail. You'll have to schedule a consultation, and then we can cover the artisan design, and I'll tell you exactly what you'll require. Thank you all for your support. Take care.